Good morning to all of you. Myself, Professor N.V. Arpe from SNT College of Engineering and Research Center, Yeola. Now, today we will discuss the new topic of course, numerical methods and computer programming. In that, today we will discuss the floating point algebra. So, what is the floating point algebra? In previous video, we already studied that the normalized floating point form. In that, what is normalized floating point form? The number, no any number or the no any decimal value which will be present before to the left of the decimal point. Means there is no any number to the left of the decimal point. Then and then the number is called as normalized normalized floating point form. Normalized floating point form. Now in today's video we will discuss the floating point algebra. Floating point algebra of floating point numbers. Suppose we take one example. Suppose add the following two floating point numbers, that is 0.471923 into 10 raised to 7 and B is 0.783329 into 10 raised to 7 to 10 raised to 7. In that here the exponents are equal and the numbers are in normalized form, normalized floating point form. Means for floating point algebra there are two steps. First, convert the numbers. Into the normalized floating point form. Second, for addition and multiplication, make the exponents equal. And after that, perform the operation, that is addition or subtraction. In that problem, the numbers are in normalized floating point form and also the exponents are same. Then we will directly add the two numbers, that is 0.471923 into 10 raised to 7 and 0.783329 into 10 raised to 7. Then the answer is 1.2552 into 10 raised to 7. Then this number will convert into the normalized floating point form. Then we get the 0.12552 into 10 raised to 8. This is the solution of that problem. Second, add 243.31947 into 10 raised to 17 and 32.1698 into 10 raised to 14. These are the two numbers are given. Then, according to the step, first, the numbers will be converted. First, we convert the numbers into the normalized floating point form. Then, the number is 0.24331947 into these three numbers are transferred to the right side of the decimal point, then the exponent is increases, that is 17 plus 3, that is 10 raised to 20, and 32 is transferred to the right of the decimal point, then the number is 0.321698 into, add 2 into the exponent because the two numbers are transferred to the right side, then 10 raised to 16. Then next, after that, we make the exponents equal. Exponents equal means the 16 will be converted into 20. Then it will be converted by adding the 4 significant digits before the 3. Before the 3. That is 0.4 times 0.321698 into 10 raised to 20. Then now we add the numbers directly. Then after the addition, the addition is 0.2433516398 into 10 raised to 20. The number, the answer is are in normalized floating point form. Therefore, this is your final answer. That is 0.2433516398 into 10 raised to 20. This is the addition of, this is the final answer after the addition of these two numbers are in normalized floating point form. Normalized floating point form. Now take the third example, that is subtract the following floating point numbers into, that is 0.394263 into 10 raised to 7 and 0.24132 into 10 raised to 7. In that, both the numbers are in normalized floating point form and the exponents are equal. Then directly subtract the numbers, that is subtract the numbers 0.394263 into 10 raised to 7 minus 0.24132 into 10 raised to 7. Then after the subtraction, the answer is 0.1528963 into 10 raised to 7. These answers are in normalized floating point form, and this is your final answer of that numerator. Next, again subtract the following floating point numbers 416.21943 into 10 raised to 18 minus 37.9341 into 10 raised to 19. First, convert these numbers into the normalized floating point form. Then the number is 0.41621943 into 10 raised to 21 and 0.379341 into 10 raised to 21. These three numbers are transferred to the right of the decimal point. Therefore, add 3. Adding that, add 2. Therefore, 18 plus 3 is 21. 19 plus 2 is 24. The exponents are equal. Then after subtract the numbers from each other, and after that the answer is 0.0368784 into 10 raised to 21. Convert it into normalized floating point form. Then 0.3687843 into 10 raised to 20 is the solution. Next is multiply. this two numbers, that is 47.31834 into 10 raised to 15 and 3.1942 into 10 raised to 12. First, convert the numbers into the normalized floating point form. That is, after the normalized floating point form, 0.473184 into 10 raised to 15. These two numbers transfer to the right side of the decimal point. Therefore, add the two. That is 15 plus 2 is 17. First, one number is transferred to the right of the decimal. Then add the one term. That is 0.31942 into 10 raised to 30. And take the product of the numbers and add the exponent. Add the exponent. Means the multiplication of these two terms and the addition of the exponents. That is, the multiplication of these two terms is 0.1511442441 into 17 plus 30 is 10 raised to 30. Next, and last one is evaluate 317.23 into 10 raised to 33 divided by 32.17 into 10 raised to 18. First, convert it into normalized floating point form. Three digits are transferred to the right of the decimal point. Therefore, add 3 in that exponent, that is 33 plus 3 is 36. And two numbers, two digits are transferred to the right of the decimal point. Then, then the number is 0.3217 into 10 raised to 20. Here, which is a typing mistake, that is this is 20. And 30, then the divide the two terms, that is 0.31723 and 0.3217 and subtract the exponent, that is 36 minus 20, it is 16. Therefore, the answer is 0.986105 into 10 raised to 16 is the solution. This is your algebra of normalized floating point numbers. In that lecture, we studied the algebra of normalized floating point number, that is addition, subtraction, multiplication, and division. Now, in next lecture, we will see the types of error. What is the error, types of error, and how to minimize this error. So, stop here.